Three coplanar forces act at the point. Magnitude of the forces are 5, 6, and 7, and directions in which the forces act are shown. Find the magnitude and direction of the resultant of the three forces. Okay. So, okay, let's say that the resultant is going to be somewhere over here. Not sure though, but I'm just assuming. Okay, so we need its magnitude and also its direction. So direction would be like these many degrees above the 7 Newton force, or anti-clockwise these many degrees from the 7 Newton force. So we need the magnitude of R and we need the direction of R, which includes finding the angle. Okay, for R, we know we have to square root its x component and y component, basically apply Pythagoras on its x component and y component. Okay, how do we find x component? We find x component of these three forces and add the ones in the same direction and subtract the ones in the opposite direction. So this horizontal component is just 7. This horizontal component would be 5 cos 50. So we have 7 plus 5 cos 50 in one direction minus 6. This is 6 cos 30. Okay, this is going to be Rx, and for Ry, it is going to be, we're going to add the forces in y direction that are in the same direction and subtract the ones in y that are in the opposite direction. So let's see what are the y components. So for 5 Newton force, this one, we have 5 sine 50 in one direction. There's no y component for this force. And for the other one, it is 6 sine 30. Okay, forward force is going to be the one that is bigger in magnitude. So 5 sine 50, that is 3.83, and 6 sine 30 is just 3. So the upper force is bigger. So we're going to do 5 sine 50 minus 6 sine 30. This is going to be the Ry force. Now you apply Pythagoras on this. We can find it individual values. 7 plus 5 cos 50 minus 6 cos 30, which gives 5.017785. Retain as many decimal values as possible to avoid premature rounding. And Ry is coming out to be 5 sine 50 minus 6 sine 30 is 0.833, no, 0.830222. Okay, this is going to be 5.017785 squared plus 0.830222 squared, okay, which gives 5.086 rounded to 5.09 newtons. Okay, for theta, it's going to be tan inverse Ry over Rx. Okay, Ry is 5, no, sorry, it's 0.830222 upon 5.017785, and we take tan inverse of this. That will give us the angle. So 0.830222 divided by 5.017785, shift tan. I'm getting 9.39 for it. which is 9.4 degrees in one decimal place. So you have to write the full direction. So this is the angle that we got. Okay, so we're going to write the direction is 9.4 degrees. This direction is anti-clockwise from the 7 Newton force. Okay. Now, there's a common question that students ask here is that how did we know that this R was here? Why can it not be here? Why can it not be in any other direction but the one I made? Okay. You figure out where R is through these resultant values. See, your Rx came out to be positive. If Rx is positive, that means it's this direction. In case your Rx would have come out to be negative, then Rx would have been in this direction. Also, our Ry came out to be positive, so that means it's in this direction. And if it were negative, we would have gotten this direction. So depending on the sign of Rx and Ry, you can tell which quadrant does the resultant force lies in and hence the alpha lies in. For example, had we gotten a negative Rx and a positive Ry, that would have meant that the force is here, the resultant force. Then we would have said that this direction is alpha degree clockwise from the negative x-axis. Okay, so you have to keep this in mind as well.